Good afternoon, everybody. I hope we're all doing well. Nice day out there. Make sure you get a bit of fresh air, but remember, keep your distance from other people as well, guys, just for the times that are in it. For the next 20 minutes, 25 minutes, I'm going to try and cover a few other areas within coordinate geometry. The first thing I want to look at, and this is in relation to a couple of questions yesterday, when we were talking about the line of intersection yesterday, when we were doing the dihedral angle, we were looking at, having a line given in a question, for example, in this arrangement here, where we had two planes, ABC and ABD, and they shared a common line in the elevation and the plan view. And we developed our question on from there. However, what happens when we don't have a common line? What happens if we only have a common point between two planes? And what happens if we only have two planes and they have no common point or line? So I'm very quickly going to cover over both of those, because in this first scenario, you have a line of intersection. Here it is right here, the line AB and the line AB. Okay, that's just the elevation. That's the plan view. And of course, you can see I've colored in the planes there as well, just so we can separate everything. Now, so we've covered this pretty much yesterday, so I won't delay any more on that. We have the line of intersection here. That means we can then, in the plan view, if we want, base our following views off of that. Type 2, two planes with a common line. So, for example, I have a plane here, ABC, and I have a plane ADE. Now, both of these planes share a common point here. It's point A. Now, what I want to do in this situation is I want to find another common point between both of these planes. And if I can find the second common point, I can join it to the common point that I already have. And if I join 2 points, I get a line. Okay? And that line would be my line of intersection. Is that okay? I hope so. Now, what we're going to do in this scenario here is I'm just going to bring my equipment up here. Is we're just going to take what is called a cutting plane, a horizontal cutting plane in the elevation. Now, how does that play out in terms of the actual 2D drawing that we have? Essentially, it's going to be like a level line in the elevation. Now, that level line is going to cut through both planes, okay? So you can imagine me, if I had an apple or an orange, I would cut, and I would get a cut surface. So essentially, with a cutting plane, we're cutting through the 2 planes that we already have, and it's given us a different type of a surface. And from that, we can generate a second common point. And with that second common point, we can join it to the common point we already have, which is at point A, and then we can form the line of intersection. So I won't overcomplicate it, guys. What I'm going to do is I'm going to actually create that cut line now in the elevation. I could take it anywhere so long as it cuts through the 4 lines, okay? Both planes. If I took it here from point D, I'd only cut 2 lines, or if I took it just through here, I could make that work. So we need to be mindful that we're cutting through the entirety of the planes, okay? So what I'm going to do here is I'm going to go to point B because it's nice and handy. It's a point that I already have, and I always encourage anyone when they're doing this to pick a point that's already there and take a cutting line like so. So you can see this line that I've added here now. Where that line passes through the lines of the planes ABC and ABD, I'm going to locate points. So I have point B, that's there. Plane on the line ED, I'm going to call that point 3. Now, I'm going to drop those points down into the plan view, like so. So point 3 is going to go down to the line DE. And again, guys, I'm always on about labeling, all right? It makes things so much easier, okay? Taking point 3 down to the line DE because it's on the line DE in elevation. So there are no questions now about where that line is meant to go. Point 2 is on the line AC. So I bring point 2 down to the line AC in the plan view. Make sure we're nice and accurate there. And here we go down here. And again, I'll label these points now as I find them. So there's point 3 that I brought down a moment ago. There's point 2 that I just brought down there now, and I have point 1 to bring down now. Point 1 is on the line AD. So I'm going to drop that line straight down, point 1 to the line AD. And I'll write point 1 in beside that. Okay, so hopefully you can see that. The zoom is kind of, I'll try and refocus a little bit there. Hopefully that's a bit clearer there for you now. All right. Now, so I have point B, which is already there. I have point 3, which is on the line DE. I have point 2, which is on the line AC. And I have point 1, which is on the line AD. Okay. Here's the key thing with this. When we're connecting these points here, what we want to do is we want to connect the 2 points that are on the pink plane. And if you're colorblind, apologies, or color deficient in any way, the plane ADE contains 2 of the points, 1 and 3. We're going to join them. So I'll focus on that first. So 1 and 3, join them because they're on that plane ADE, which is the pink plane, like so. Point 2 and point B are on the plane ABC. That's the blue plane. So we're going to join them. Both of those lines now, they cross over here in the plan view, like so. That there now, that is my common point that I've found. That is the point that I can now help or use to create the line of intersection here in the plan view. So with that said, point A is the point I already have. And now I've found this new point, and we'll just call it point P. P for point. And we're going to join A to that point. Now, that technically is our line of intersection in plan. What we would normally do in this situation is we would just normally run that line on to hit the next plane. Like so. I just heavy it in. And there we go. That's our line of intersection. I just go LOI. Line of intersection. If I want to locate that in the elevation, quite simply, I'll get my set square. Where I extended it on, you can see right here, it hits the line DE just before it hits the other line. I can take that point up to the line DE here in the elevation. Bring it up. There's the line DE. Hits right there. You'll see it right there. Okay, there's point P in the elevation. And it's not even a huge necessity to draw that point up into the elevation because sometimes you don't even need it there. But I think to be transparent about everything, we should always include that detail. And again, I will join the line from A, and that gives me the elevation of the line of intersection. Okay. Now, if we were asked to find the dihedral between the 2 planes, we would set up an X1, Y1 parallel to the line of intersection in plan view and proceed just like we did in yesterday's lesson. And if you want to recap on that, guys, you can just go back into the live stream playlist and play that video from yesterday. You'll also find support material in the other playlists, in particular DCG cheats and also DCG playlist itself. Okay, moving on to the next one, guys. So I'm just going to focus in on the side over here. The type 3. 2 planes here, ABC and DEF, and the thing that these planes have in common is that they have nothing in common other than that they're both planes. Okay, we've no common point that they share, and we have no common line that they share. So what we've got to do now is we have to construct a line of intersection between both of these planes, and yet we have no reference to do so in the first place. So what are we going to do? Well, we're going to do exactly what we did in this one here. We're going to use a cutting plane. All right, create a level line. All right, we're going to find a point, but the only thing different we're going to do here is we're going to use that method twice in this one here. Okay, that's all we're doing. Now I'm going to select 2 points at the start here for this process. I'm going to take a cutting plane, level line through point E. So I'm going to cut across there, and I'm going to do the same from point C. Okay, now again, as I say, you could take that cutting line anywhere so long as it's cutting through both planes. If you want, you can try that out yourself. For the moment, I'm just going to stick with the regular points that are already there so we can make things nice and clear. So I'm going to point E. I'm going to draw a level line, cutting plane if you want to call it that. And I'm going to highlight where it passes through the lines of the planes that we already have. So I'm going to call this point 1. I'm going to call this point 2. I'm going to call this point 3. I think you're seeing a pattern with this now. For the other cutting plane, I'll use a different color for that one so that we can see the difference between both lines. So I'll take a red color. And again, you can see colors and labels. I'm always coloring and labeling because it just helps to visualize the whole process. Now, I don't know how clear those colors are to you at home, but one line is purple, the other line is red. So from point C here, I'm going to go locate points. And rather than call them 1, 2, 3 on this one, I'm just going to call them 4, 5, and 6. Now, I'm going to focus on that cutting plane, that level line in the elevation that I already have. I'm going to concentrate on that one first, and I'm going to locate points 1, 2, and 3 in the plan view, just like I did with this example here a few moments ago. So I'll take my set square, and I'm going to bring point 3 down. Now, point 3 is on the line AC. So that's all good. So we'll go down to the line AC with that point there. And the minute we get down there, guys, because we're going to have extra points this time, label them straight away. There's 3. 2 is on the line DF. So I'll bring 2 down to the line DF. So bring it on down. There we go. There's point 2. Point 1 is on the line AB. So I'll bring point 1 down. And didn't really come out there. Now there we go. Okay. There's point 1. While I have that information there now, I'm going to join up what I need. Okay. So if we can see here, with that cutting plane at point E, we've generated the points 1, 2, and 3 in the elevation, and we've located them in the plan view. Okay. Following our labels and our numbers and so on, and that keeps things nice and simple. What I want to do is I want to join those up properly now. So again, we're going to focus on what points are on what plane. I have the plane ABC, and that contains points 1 and 3. So I'm going to join them in the plan view. So 1 is going to get joined to 3. So I'm lining up 3 and 1 here, like so. Point 2 and point E are on the plane DEF. So I'm going to join them. Where both of these lines intersect here, that's our point on our line of intersection. But it's just one point because we have to use the second cutting plane line now to generate a second point. So we'll call that point P1. Okay? And we hope now that we can find a second point, P2, and be able to draw the actual line of intersection between both planes. So I go back up here to my cutting plane at point C, and I have points 4, 5, and 6. So I'm going to project them down now. Point 4 is going to go down to the line DF in the plan view. So 4 down to the line DF. There we go. So, and I'll immediately write in point 4. Point 5 is on the line EF. So I'll project all the way down to EF here in the plan view. There we go. And we'll write in point 5 there. And then point 6 is on the line AB. So I bring a line down from point 6 to hit the line AB. It hits right here. And I'm going to mark in point 6. Okay. So I want to establish again what points on this cutting plane are on the planes that we have. So for example, if I look at point C and point 6, they're both on the plane ABC. So we're going to join them in plan. So I'm going to get my red pen, okay, and I'm going to join point 6 and point C. So you'll see this. There we go. Now, The next set of points we have are points 5 and 4, and they're contained on the plane DEF. So 5 and 4. So here's 4 and here's 5. So what we're going to do now is join them. Now you'll notice here, and this is quite a common thing when we're doing this type of arrangement, those lines don't cross over, do they? No. You can see 4 and 5 that line created doesn't intersect the line C and 6. And this happens, okay, depending on the arrangement of the planes. And in this case, these lines don't intersect. However, what we do is we extend those lines until they do intersect. So what I'll do, and I'll use a dotted line now to highlight this, is I extend on the line 5 and 4 in the direction to where I think the two lines may intersect. So I've extended the line on there, and the line C and 6, I will do the same thing, and I will extend that on like so. Now, we have the point located. And you might be saying, well, that point there, that point P2, that's not in the planes there. That's irrelevant. We would have located a point, whether it's external to one side or not. It's a point on a potential line that is infinite, that infinitely intersects these planes. We've located a point on that line. So that's a valid point that we can now use. And all I have to do is simply join up P1 and P2. Now, as I do this, I will draw that line lightly first, like so, lining up P1 and P2. You'll see that line very light. And I've drawn it light because I only want to heavy one part of that line. I want a heavy where it hits the first plane coming in here and the last plane over on this side, just to contain that line and give it a definite length, I suppose, if you want to call it that. So now I have the line of intersection right in there. Okay, here's the point here and here. Now, to complete that, bring them up to the elevation. I have one point if it's on the plane AB. So I'll bring it up to AB there. Lands right here. And then I have a second point which is on the line DF, ever so slightly. So I go to the line DF here. There we go. And I will take that one on up like so. And there we go. Okay. Now I'll join them here in the elevation. And that is my line of intersection in the elevation. Okay. So from that, if I was going to work out a dihedral angle between both planes, that would be the necessary construction work to find your line of intersection. Then you could proceed from the plan view if you wished, with your x1, y1 parallel, get your true length of the line of intersection, then take a second auxiliary view, which would be perpendicular to the true length, and you would find the dihedral. So, as you can see, with the methods that we have here, the first one, we had the line of intersection given to us due to the arrangement of the planes, and they both sharing two common points, which gave us a line, and that being a line of intersection. Here we had one common point, so we had to take a cutting plane, generate a series of points that we could connect in plan to give us a second point on a line of intersection, so we could actually form the line. And thirdly then, in the example we've just gone through, we had to repeat the method we used in type 2, we had to repeat it twice in type 3 to generate 2 points on the line of intersection. And as you can see, there's a little bit more work in it, but it is just replication. The key thing with this is label your points, okay? Take one set of points at a time, relate them to the correct lines and the correct planes as you transfer them from one view to another, join them correctly, i.e. 2 points on the blue plane, join, 2 points on the pink plane, join. Crossover point is a point on the line of intersection. So I guarantee you guys, you nail that method, you label your points, and you won't go too far wrong. Okay, so if you have any questions about that, feel free to there's information there. My website detail is there, info@lio.ie. You want to ask any further questions, so just drop a little email if you want. I'm happy to answer. Other than that, I would suggest, if you're looking back over the video, take a little screenshot of the solutions so that you can use a kind of a visual aid as you're doing your own revision as you go along. Okay, now I'm going to move things on. So I'm going to take this sheet off, guys, now. Now, I'm a bit like Jamie Oliver. Here's one I made earlier. Now, okay, so we're going to look at the scenario, guys. When you have one of these questions, okay, coordinate geometry question, and you're missing the information for one of the coordinates. For example, in this setup here, I have the coordinates for B, D, and E, all right, in the elevation, and I have B, D, E, and F in the plan. However, F is missing in the elevation. I wasn't given the coordinate for that point. Now, there are a multiple of ways where F can be found depending on the information given. Okay, so I'm not saying the method I have here is going to solve this particular problem all the time, nor is it going to be the most efficient way all the time. But in the context of this scenario, we are given a piece of information. It says the dihedral angle between surface BDE and DEF given as 170 degrees. So, normally speaking, we would have to find a dihedral angle in a question. This time, it's given to us between two surfaces. And the reason it's given is because we have to backward engineer our dihedral angle in order to find point F. And that's what we're going to do exactly here. So how do we use the information, and this is the key question, how do we use the information given to find point F in the elevation? Well, straight off, I am going to proceed as normal. Forget about F in the elevation for the moment. Go to your plan view. You have a completed plan view right there. And what I'm going to do is I'm going to take the first step to creating a dihedral angle, okay, between the two planes. Now, you might say, well, it's already given to you. Yes, it's given in written form, but what we want to do is we want to graphically represent that piece of information. So we're going to go ahead and do that. So I take my set squares. I'm going to set up my X1, Y1 line parallel to the line of intersection here in the plan view. That's the line D, the line that's common between both planes. Okay, and we've just after talking about the different types. So again, this one is nice for us because we don't have to go figuring out the line of intersection. It's given to us, okay? And we're going to draw our X1, Y1 parallel. So there's X1, Y1, okay? I might just move the board a little so you can see that bit that's down the bottom. Right there. Hopefully you can all see that at home, guys. Now, the points here in plan, I'm going to project them out now at a right angle, okay? So, I have already pre-drawn these lines very lightly. So, set your points up at a right angle, or your set squares. And what we're going to do is we're going to project those points out to their necessary position, all right? Again, I have the points already kind of pre-marked. You shouldn't be able to see them too well at home, but I have them done very lightly so I can speed things up. So I'm going to project out the line from point E, and that's at a right angle to the X1, Y1. I'm going to do the same for F. Now you're going to notice here, I'm going to stop F at the X1, Y1 line, and then I'll continue it very lightly, but I call it tentative line because I don't know exactly where F is yet at the moment. And then D, I'm going to project D out, and obviously B as well, which is off back there. Okay, now when I project from plan, I take my measurements from the elevation, guys, okay? So for point E, I go to the elevation here, and I take the distance for E like so, and I would go down here and I would step it off, okay? So there's point E, and I'll write in E straight away there. Get my black marker for that, point E. I'm going to do the same. I've take the distance for B, So again, take the distance for B. You can see there, I need to stretch the compass out a little bit more. There's B. Follow the line for B out to the X1, Y1 line and step it off. And that'll be my point B. And then point D, same thing. Take that, step it out. There's point D. And finally, point F. Oh, where's point F? Point F is missing. So we have to leave that bit out. Okay? So all we can join up is D, B, and E. So I'm going to do that. And that's the pink plane. So I'm going to use my pink pen here now to join up the points. And that line DE, okay, if you look at it in each of the views that we have, that is already highlighted as our line of intersection. And it's going to be no different in this view. So with the green pen here now, I'm going to highlight this one as the line of intersection. And it's not just a normal line of intersection. This is the true length of the line of intersection, okay? TLLOY, okay? So I'll just try and lean that camera forward a little bit more. There we go. Apologies about that. And there we go. Now, so you can see the full view there, TLLOY. What I'm going to do, when I have a true length of a line of intersection, I can set up my auxiliary view at a right angle to that for the dihedral angle. So this is an auxiliary elevation here. This is, our next view is going to be an auxiliary plan view. We talked about that the last day. But before I move on, just so we're nice and clear about where everything is, I'm just going to shade in my plane here, just so we can look back over the views and see what's what. And you see I'm going to leave a little area kind of clear there beside it because I don't have point F to go colouring in the plane next to it. Okay, I will use my yellow then just to highlight around the area that in this particular auxiliary view, it's an auxiliary elevation. Why? Because we projected from plan, we took the measurements from the elevation, and when we take something from the elevation like that and step it out, that means that this is also an elevation, an auxiliary elevation. So that's great. That means our next view then is going to be an auxiliary plan view. And if we kept going for another one after that, the auxiliary elevation, then auxiliary plan, and that will go on to infinity, and we get views and views and views of everything, the same information. Now, so I'm going to proceed on to my auxiliary plan view. I'm going to set up my x2, y2 perpendicular to my true length of my line of intersection. Now, I've already pre-drawn the line, so I'm just going to heavy that in so you can see it. Like so. So I'll call this x2, y2, and that's an auxiliary plan view that's going to happen here. I'm going to project out now at a right angle through that. Again, I have those lines pre-drawn already. So I'm going to draw out points D and E, project them out, and point B, project that out. And again, if you're worrying about where these measurements are coming from in this one, we are going to go to the X1, Y1 line and step back to the points in the plan view. Okay, so you can see there, I have my compass on my X1, Y1, and I'm measuring back to point D. That's going to also cover me for point E. I'm going to take that distance and I'm going to step it out. And you can see that that gives me my point there. Well, it actually gives me a point view of the line DE, or the true length line DE. So it now becomes a point view. So that's D and E as a single point, one in front of the other. My point B, I'm going to take my compass, X1, Y1, measure back to B, head to my projection line from B to where it is on the X2, Y2, and step it off. Now I have point B located. And I'm going to join them up. And that's going to be a pink line. Again, that's representing the plane BDE as an edge view. Okay, and we talked about the creation of the dihedral angle essentially being the edge view of both planes, and the 2 points that are in the middle, the point view is actually where the angle is contained. Okay, so I have the edge view of the plane BDE there. How do I go and find this elusive point F? Well, I'm going to go back to the information that was given in the question. It said the dihedral angle between surface BDE and DEF given as 170 degrees. So what I'm going to do is I'm going to get my protractor, I'm going to put it on the line BDE at the point DE, okay? And I am now going to mark 170 degrees. You'll see there's 170 degrees. I'm marking the point there. And I'm going to draw a construction line from DE, okay? This is going to be just a light blue line like that. Don't worry about the length of that line. We're going to figure all that out in a second, so don't panic. Just draw it. What I will do while I'm here, just so we're ticking all the boxes, get my compass. I'm going to swing from DE just to highlight the dihedral angle, because we're professional and all that. We're going to highlight that angle as being the dihedral angle. And write in dihedral angle there as well. Okay, so that's dihedral angle wrote in there, and that's 170 degrees if you measure it. How do we find point F? Well, point F is on this blue line somewhere. Now, here's the thing where you need to think a little bit outside the box, okay? But once I tell you this, you won't have to really think outside the box anymore for this particular thing. So, what I'm going to do is I want to acknowledge, where did I take these measurements from? In this view, where did I get them from? I got them from the X1, Y1 back into the plan view. Yeah, so I took them from here back into here. Now, I have something that stands out very obviously to me. We have a point F in the plan view, don't we? And I'm just going to highlight that. There's point F. So, would it not be reasonable for me to take from the X1, Y1 line back to point F? That distance. We'll call it distance. We'll call it D1. Distance 1. So I'm going to take that distance 1, okay? And what I'm going to do is I'm going to go to the X2, Y2 line, and I'm going to step it out off the X2, Y2 line anywhere. It doesn't matter. Just step it off. If you want, if you want me to keep it consistent, I'll take the projection line for D and E and I'm going to step it off on that so we can actually see it as a point, okay? And I'll write in, this is D1, distance 1, okay? And there it is right there. Now, all I have to do, guys, in this situation is I'm going to get my sliding set squares, line it up with X2, Y2, go to the point I just marked out, and I am going to draw a line now that is going to be parallel to the X2, Y2. That's going to intersect the blue line that I drew for the 170 degrees. Okay? And where that line, and I'll put in a little parallel symbol there if you want. Okay? And if you want, I'll even highlight with arrows that I marked out D1 on that line. Okay? Where I marked out D1, and it intersects here, gives me this point. That, folks, is your point F. Okay? That is point F. Now, the reason being we can confirm that is because point F is on this blue line. It has to be. Okay? Because that's the edge view of the plane. We just didn't know where F was exactly on that. And we had a piece of information in this view here that we could use because we used the measurements from this view to create this view in the first place. So we could take F and we could apply that distance to intersect with the line that we had. And that allows us to find point F. Now you might go, well, what use is that? Because this is auxiliary plan view and we need to find F in the elevation. Well, let's tie this up right now. So what we're going to do, we're going to project that point F back at the same angle we projected all the other points out at. So you'll see now, I'm going to take point F back into the auxiliary elevation, all the way to hit that tentative line. If you remember that word I was using earlier, from point F that I drew out. I drew out that line, I drew it blind, I drew it any length. Okay, I am now taking the point F back to intersect that line. What I have now is I have point F in the auxiliary elevation. Now, if we are able to put 2 and 2 together here, we'll be able to locate that point in the elevation itself. How would we be able to do that? While I colour in, you have a little think about that. I can hear can see all the light bulbs coming on in there now, lads. This problem that you haven't been able to solve properly, if it has been a problem for you, you're beginning to see the solution to it now. And again, I'll just highlight outside the planes here. Now, point F. What we have here, when we created this view, we took all the measurements from the elevation. Okay? So, essentially, if we have found F here, we can use the distance between the X1, Y1 line and F as a measurement that we can use in the elevation. Why? Because these are both elevations. They're both plan views. Okay? So now we have F in our auxiliary elevation. We can use it in our normal elevation. So all I'm going to do, and I'll firstly, before I move it on, I will reference that particular distance. Okay? So just with a little dimension line, just so you guys can see it at home. This distance between the X1, Y1 line and point F, that is the distance that we are going to take. I'm going to call that D2. Remember we used D1 earlier? That was for the initial F here. We're using D2 now for the elevation. So I'm going to take that. You can measure with your ruler, your set square, or you can get your compass. Take the distance like so. Go to the line F here in the elevation. I'm going to extend up my construction line now to meet that particular point. Like so. And I can write in right there now with a great degree of certainty that that is exactly where my point F is. So I can just join that up and join that up. And we can now complete the elevation view. Okay. And again, true to form, a little bit of color there. So we can just see the plane that it's relevant to. And you can see there as well, guys, there wasn't a huge amount of new learning there. It was identifying what planes, what views represented what. We were able to continue on with this question without one of the points most of the way because we were given a bit of information that was going to assist us in the final stage of it. And once we had that, we then just have to look at the information we have in our different views, like this is an elevation, that's a plan, that's a plan. So if I have one measurement in one and it's a plan view, it relates to the other and here likewise. So it's all about thinking a little more clearly about the information that you actually have and not about what you're actually missing. Because if you focus on what you're missing, then you're going to create a little bit of panic, and we don't want that whatsoever. Okay? Just going to highlight those lines there that are representing our planes. One thing I didn't do was heavy in the proper color of blue for defining the length of the line there. And we can just shade around that a little bit as well. And of course, all that dihedral angle that we found is situated within an auxiliary plan. Okay, and we just want to highlight that information like so, so we're nice and clear about everything going forward. And I will write that in. This is an auxiliary plan. And this was an auxiliary elevation. Okay, so lads, that's that bit complete. Okay, we've completed out the question. We now have the completed planes here in the elevation. We have demonstrated where we've taken necessary distances from, combined information that was given in written form went through our stages like we normally would for a dihedral angle, and look, everything just works out. It's just knowing how to use the information given to find the point F in the elevation. That's what we had to figure out, not what we didn't have. Okay, so thanks very much for that. If you want any recap on that or anything like that, or you want to follow up, just email me info@lio.ie, or you can go through the playlists, and again, you'll find similar material to that in digital resource form, and work away at that. Okay, now I have one more aspect to today's lesson. Again, here we go. Here's one I prepared earlier. What we're going to do is we're going to have a quick look at this one. It's actually not as much work as you'd think in this at all, even though I've given quite a lengthy rationale, but that's just to kind of make sure that we understand the stages that are involved in it. Quite simple. And then the logic behind it. Okay, so finding the inclination of BDE to the HP. Now I have two planes here. I have the plane BDE and the plane DEF. Okay, so I don't want you to worry about DEF. All right, I've put it in as a distraction. All right, because often in the case of, let's say, an exam situation, and I don't always mean to be teaching toward the exam, but most of you guys tuning in are leaving cert students, and the potentiality is, you know, your exams will be as scheduled in June, and we want you to kind of be comfortable in the situation where if you are asked for the finding the true inclination of BDE to the horizontal plane, then that you're able to go ahead and do it. Okay, and it's quite simple. What I'm going to do here, I have the elevation, I have the plan view. I'm going to take a cutting plane, similar to the cutting plane that I would have taken in the initial part of this lesson where I was doing the line of intersection. We don't want a line of intersection this time. What we want to generate is a line on the plane itself. We're going to focus on the plane BDE, and we want to get a level line there in the elevation. Okay, just technically that line really results from a cutting plane if we were to apply it. So I'm going to use, where's that light blue? There we go, from point E. And you might go, well, why point E? Well, point E is the point that's between B, which is above, and D, which is below. I couldn't take a level line from D. Sure, it wouldn't hit the plane BDE, would it? Or likewise from B. But if I take a level line from E, I get a line that I can extend over to hit another line on the plane. Okay, and I'm going to call that point 1 right there. So E travels over, there's the level line as a result of a cutting plane, gives me point 1, which is located on the line BD. Now what I'm going to do is I'm going to drop that particular point down into the plan view. Where is point 1 going to go to? It's going to go to the line BD. Here it is in plan view. So I'm just going to draw it down as far as there. Okay, I'll put a little arrow on that one just to show you that that one's moving, and we'll locate point 1 right here. There we are. There's point 1. Now what we have to do, guys, is we have to connect 1 to E in the plan view. And you're going, well, what's this level line now, and what's it doing here in the plan? What we have, if I just put LL there for level line, what we have here is the true length of LL. Now, if we think about all the work we've done in the previous lesson and the work we've done in the lesson so far today, when we have a true length of a line, it doesn't matter whether it's a level line or a line of intersection, whatever it is, once we have a true length of a line, we can set an auxiliary view up at a right angle to it or perpendicular to it. Okay? So what I'm going to do is I'm going to set up an X1, Y1 line perpendicular to the true length of the level line here in the plan view. So I have that line pre-drawn. Okay, just going to locate it out here, and I'm going to call that X1, Y1. I'll just extend it on a little further there, actually. Okay, so there's my X1, Y1 line. Okay, that's at a right angle to the true length of the level line that we have here in the plan view. What I'm going to do is I'm going to now project out the points D, B, D, and E out. Okay, now if I project them out from the plan view, this means this is an auxiliary elevation. So the measurements I take for this one, I take them from the elevation. Okay. So again, I have those lines pre-drawn, so I'm just going to project them out. You will have to use your sliding set squares. This just speeds things up for me. So there's B brought out. There's point E and 1. And you remember, E and 1, if you take them, they're the same height because they're a level line. Okay. And point D then finally. And don't worry about point F. The blue plane is there as a distraction. Okay. So I'm going to join those points up, but before I do, I'll just label them. All right, B, E, we'll call 1 there as well if you want to include it, and D. If I join those up, they should join up in a straight line. Okay, and that plane, the plane is pink. Okay, so I'm going to join them like so, and of course they join. Lovely. Now, what we got here is we got the edge view, okay, of the actual plane BDE. So that edge view now, all right, to find the actual inclination to the horizontal plane, all we have to do is extend that line all the way down here now to the X1, Y1 line, okay? Now, if I measure the angle there with my protractor, okay, the angle is 50 degrees, okay? So theta equals 50 degrees. So that, guys, is the true inclination of the plane BDE to the horizontal plane. It's as simple as that. There's nothing more to it, fellas. It really is. That's all it is. Okay. And that typically, it can come up as a part C or a part D in your coordinate geometry, or it could come up in your oblique planes. It can also come up in surface geometry in a different way. Maybe if you're just trying to find the edge view or the angle of a surface to the ground, which so happens to be the inclination of a surface to the ground, to the HP. Okay, so that's that located. Guys, again, if you want any follow-up explanation, feel free to email me at info@lio.ie. That's info@lio.ie. You will also find in my resources that are on YouTube there in the playlist, if you go to the playlist named DCG Cheats, you will find that specific method in a digital format, and it also links on to some other elements, for example, finding the true shape of that surface, or finding that plane relative to the vertical plane as opposed to the horizontal plane. So feel free to have a look at those videos to assist further learning that might be related to this. Okay, and look, guys, thanks very much. Again, continue to be safe. You know, think about the people in your communities and in your families, about the coronavirus situation. Hard to be sensible when you're young, all right, but please, we'd all just ask if you can, you know, row in for the time being, and you know, it'll help the situation to calm down all the quicker. Okay, so all the best. I will be tuning in live again on Thursday for DCG at 11:55. And anyone who's interested in technical graphics that's looking at this now, I'll be doing technical graphics tomorrow, surface developments at 10:20. I'll be streaming live. Okay, so anyone who's interested in that, look forward to seeing then. Okay, otherwise, be safe, stay well. Good afternoon, good evening, and good night.